Have you ever wondered why people buy insurance yet also purchase lottery tickets? Buying insurance reflects risk avoiding behavior, seeking to avoid financial loss, while buying lottery tickets shows risk loving behavior, chasing uncertain but potentially large gains. Surprisingly, many individuals engage in both of these risk avoiding and risk loving activities. This apparent contradiction has long puzzled economists who have sought to understand why the same person might simultaneously avoid risk and seek it. One influential explanation comes from economists Milton Friedman and Leonard Savage. Let's explore their insights, starting with insurance. Imagine your net wealth is 40,000 units. You face two options. Option A: buy insurance by paying a premium of 5,000 units. Option B: do not buy insurance and risk losing your wealth in the event of a disaster. If you choose option A, you pay the premium and receive compensation if your house catches fire, resulting in a guaranteed net wealth of 35,000 units. If you choose option B, you keep your full wealth unless disaster strikes, which has a small probability, and the expected financial outcome without insurance might be somewhere around 38,000 units, but it will be higher than the guaranteed 35,000 units with insurance. From a purely financial perspective, not buying insurance appears more profitable, yet in reality, people buy insurance because of higher expected utility in the face of uncertainty. Now let's consider lotteries. You have two choices. Option A: buy a lottery ticket. Option B: do not buy a lottery ticket. The expected financial return from buying a lottery ticket is typically less than the amount spent. For example, spending 5,000 units on lottery tickets might have an average return of 3,000 units. Financially speaking, avoiding the lottery is the better choice. Yet, people frequently buy lottery tickets despite the financial loss on average. So, how do Friedman and Savage explain this paradox? Their explanation centers on the concept of a unique curve, I will call it a spline, that describes how people value wealth at different levels. Also, a side note, many textbook illustrations of the Friedman-Savage utility curve are inaccurate. Some incorrectly show utility decreasing as income increases beyond a point, which is impossible since total utility never falls below previous levels as income rises. Here is the correct step from original paper. Despite some confusing illustrations in textbooks, this utility spline helps explain both insurance purchasing and lottery playing. Let's explain insurance behavior. Recall the two options. Option A: buy insurance, end up with 35,000 units of wealth. It's a certain outcome. And option B: no insurance, end with approximately 38,000 units of wealth, uncertain outcome. For option A, the outcome is certain, so utility is directly drawn from the spline at 35,000 units. To evaluate option B, we calculate the expected utility by considering 2 points. One where disaster occurs, wealth drops significantly, and one where it does not. We draw a straight line between these points to represent the different levels of probabilities of either of these two events occurring. The key insight is that due to the shape of the utility spline, the expected utility of buying insurance exceeds that of not buying insurance, explaining why people choose to insure themselves despite the lower financial return. Now let's explain the lottery behavior. Again, two options. Option A: buy a lottery ticket, uncertain outcome. And option B, do not buy a lottery ticket. Certain outcome. For option B, utility is straightforward from the supply net current wealth. But for option A, the uncertain outcome ranges from losing the ticket price to winning a large jackpot, say up to 100,000 units. We calculate expected utility by drawing a line between these extremes. The combination would fall somewhere around 38,000 units. Now that could change depending upon the probability of winnings, but we just make a reasonable assumption of 38,000. Drawing further utility, we find that it exceeds the utility of not buying the lottery. So despite the negative expected financial return, this explains why people buy lottery tickets, and that is because buying lottery tickets has higher expected utility than not buying it, and hence the decision to buy the lottery ticket.